Right, so what we're going to do is we're going to go over an example of internal resistance, and in our case we're going to calculate the total resistance inside this circuit over here. We're going to calculate the total current in the circuit, the voltage available, and also the voltage lost. So that's the voltage available, voltage lost inside this circuit. So to start us off, we're going to do part A. Part A is calculating the total resistance. So because it's a series circuit, all I need to do is just add up my components. So 20 plus 30 plus 1.5. So a lot of the time, students miss out the 1.5 there. So this is actually equal to 51.5 ohms for that one. For part B, we've got to calculate the current in this circuit. So what we're going to do is we're going to look at this equation over here. V is equal to IR. So what we do is V divided by R is going to give us I. So in our case, we've got 9 divided by 51.5, and we get an answer of 0.175 amps. For part C, we're looking at the voltage available. So we know the total current inside this circuit is a constant. It's IT, which we just calculated there. That's the total current running inside the circuit. The voltage available to these two resistors is going to be IR. So V is equal to IR this time, and R is actually the voltage in that and that available. So essentially it's 0.175 times by 50, and we get an answer of 8.75 volts. And then hang on a second, we haven't made the 9 volts up yet, so we're going to calculate the voltage lost as well, because remember, the voltage lost plus the voltage in the circuit, voltage available in the circuit is going to equal the epsilon, or the 9 volts. That's epsilon, that's the EMF of the cell. So for part D, all I need to do is V is equal to IR, and then this time I've got 0.175 times by 1.5, because that's the resistance of the cell itself. So we get 0.263 volts. So 0.263 plus 8.75 gives me around the 9 volts. And there is a bit of a difference, and that's because of the rounding errors associated with this type of question. So that's just an example of how we can use internal resistance.